A very good afternoon, all of you. First and foremost, if I'm audible and visible, please give me a thumbs up. Okay, wonderful to see. All right, so let's begin with our session today. In the last class, when we began with our module of science and technology, we had discussed the chapter of space technology. And various aspects of space technology is what we had done in our first class. Now, to carry on from there, we had started with our second chapter, and this is the chapter of energy. Now, from the perspective of energy, we discussed what are the basics of energy, what is the classification of energy, and then we had started with coal. And we had done a discussion about coal and the various aspects related to coal. So, this is where we had stopped in our last class. So, to begin from there, the next topic that we have is petroleum. Now, before we start, to give you an overview of everything that we are going to discuss in today's class, first and foremost, we'll go through petroleum. And then after that, there are certain non-conventional sources of energy, non-conventional, non-renewable sources of energy that we are going to discuss. After we have done the discussion of those topics, we'll go to the next part, which is renewable energy. In renewable energy, we'll have a discussion about solar energy, wind energy, geothermal energy, and biofuels. These are the these are the things that we are going to discuss in this session. And then after that, if time permits, we perhaps will start with nuclear energy towards the end of our session today. And this is what is in plans for you in today's class. All right. So before we begin, any questions, anything that you have from the last class? Also, if you do anything already listen to your lectures from tablets 2 times, what is your suggestion for me? So tablet lectures that I have recorded for energy, they were recorded almost a year back, I think. So compared to that, there are certain updates that we have here. So it will help you if you go through these lectures as well. It will help you in getting those updates. Otherwise, the basics remain the same. The basics are not going to change. The basics are the same there as well and here as well. So the concepts are not going to change. The structure of the chapter is not going to change. Just that there are certain updates over the last 12 months that you can say more or less, not even 12 months, almost 6 to 9 months that have been included here. All right, fine. So let's begin. So first, we'll start with petroleum. Now, before we go to petroleum and understand the various aspects of petroleum, uh, think about coal and what we discussed about coal in the last class. What we discussed is that coal is nothing but carbon, right? Carbon and maybe some mixed impurities that determines what is the variety of coal and what is the efficiency of coal and everything else, right? Now, between coal and petroleum, and let me ask you certain questions first, and then we shall begin with the discussion on the various aspects. First and foremost, my question to you is, if I ask you what are the similarities between coal and petroleum, can you name certain similarities that you think? Similarities between coal and petroleum. Okay, fossil mining, fine. Anything else? Yes, both are fossil based fuels, correct? Non renewable, perfect. Both are non renewable, yes. No, I'm just asking similarities. Some of you have also mentioned some of the differences. I'm just asking the similarities. Both can be used for domestic as well as industrial purposes. Perfect. Conventional sources of energy. Wonderful. Yes, Archana, this is one answer that I was looking for. Both liberate harmful gases. Both are hugely polluting sources of energy, right? So these are sources that very, you can say, widely is being used all across the world. But at the same time, we also realize the fact that these are energy sources that are highly polluting, and that's the whole idea about this particular chapter, why we are studying this chapter. Because after studying all these things that we are discussing about coal and petroleum, we are going to go and study about the renewable energy sources, and we'll start understanding the various aspects of the problems that we have with coal and petroleum. And I'm very sure it's the same thing that you are also going to study in your environment and ecology classes, where perhaps in the chapter of pollution all these aspects will also be considered, and even in climate change chapter perhaps these things will be mentioned. So what we also understand is that between coal and petroleum, both of these are the sources that that are very harmful, and that is why we are looking for so many sources, so many alternatives that will help us decrease or reduce the amount of greenhouse gases that we are uh, emitting right now. All right. So that's it. Yeah. So other points are also correct. Both are formed from the remains of ancient organisms. Correct. So yeah. So more or less, you all have covered the similarities between coal and petroleum. Now also let's have an understanding of the differences. That what are the differences between coal and petroleum? We very well understand that right now these two sources, they are running the world economy. Correct. Whether Indian economy or US economy or worldwide anywhere, perhaps coal and petroleum just runs the economy of any country. Now, when we look at the differences, all right, when we look at the differences between coal and petroleum, what we understand is that first difference, if we think from the perspective of the composition, from the perspective of composition, then from the perspective of composition between coal and petroleum, we understand that coal is made of carbon. Correct. Coal is made of carbon, and petroleum is made of, we say that it's a complex mixture of hydrocarbons. As you can see the definition that I've given you on the screen, that it's a complex mixture of hydrocarbons. So that is basically what we can say in terms of composition. And then after that, yeah, some of you have already mentioned some of the differences. So next is from the perspective of the source, right? So from the perspective of the source, as some of you have mentioned, that about coal, what we discussed is that this is completely plant based, right? So the source has been vegetation. The source has been vegetation. Whereas in case of petroleum, the source could have been both animals and plants. The source could have been both animals and plants. So, meaning underwater animals and plants, zooplanktons and algae are said to be the primary sources of petroleum. So, that's another difference that we have. That in a manner, you can say that coal is veg and petroleum could be non veg as well. Correct? So, that's the difference in terms of source. And then in terms of origin, another difference is in terms of origin. Now, in terms of origin, what we discussed about coal is that coal has originated, would have originated in the wetlands. Correct? Coal would have originated in the wetlands, whereas when it comes to petroleum, for petroleum, what we see is that the origin would have been underwater. Origin would have been underwater, mainly seas and oceans, but even lake bottoms also formation might have happened for petroleum. So largely the formation began, or the origin was underwater. So these are three primary differences between coal and petroleum. But apart from that, there is another difference as well. And this difference is in terms of state. The state of matter. We know for sure that carbon is solid, sorry, coal is solid. Whereas in case of petroleum, petroleum could be solid, could be liquid, or could be gaseous as well. All the three are possible. Generally speaking, when we think of petroleum, we think of the liquid form, but it's not necessary that always it will be in its liquid form. It can be solid also, it can be gaseous as well. What we get as crude oil, which is a basically mixture of different types of petroleum. Crude oil is in liquid state, but then after that, from there on, we keep on getting or extracting different fractions of petroleum. For example, petrol or diesel or kerosene, paraffin, all these things, even LPG, all these things are what? These are petroleum products. So solids, liquids, or gaseous. So all these things are possible. So although in the way they function, in the way they run the world, in the way they pollute the world, in all those cases they are similar, but when it comes to, let's say, their structure, their chemistry, etc., we find that there are differences between coal and petroleum. All right, so when it comes to petroleum, what we are saying is that it's a complex mixture of hydrocarbons. So let's try to understand what we mean by complex mixture of hydrocarbons. So for that, first and foremost, what do we mean by hydrocarbon, right? So hydrocarbon, you can derive the meaning from the word itself, hydro and carbon, meaning that this is a compound where you have hydrogen and carbon, but only hydrogen and carbon, nothing else. So any hydrocarbon has just hydrogen and just carbon. So these are, that's why called as hydrocarbon. So organic compounds composed of elements carbon and hydrogen only. So when they have only hydrogen and carbon, then in that case they are called as hydrocarbons. And for petroleum, what we are saying is that petroleum is a complex mixture of hydrocarbons. So complex mixture of hydrocarbons, meaning that there is only different there are different types of hydrocarbons which are mixed in any petroleum product. And that's why this is one thing worth noting for you, that when you think of a compound, let's say water, carbon dioxide, etc., you'll see that there is a chemical formula that has been assigned to these compounds. Correct, a chemical formula is assigned. So that's why water is H2O, carbon dioxide is CO2, common salt is NaCl, and all these. So these are compounds. But when it comes to petroleum, we are saying that it's a complex mixture, and a mixture can never have a chemical formula, right? So that's why when, if let's say somebody asks you what is a chemical formula for petrol, there is no chemical formula for petrol. There is a very complex structure that we have for petrol, where there are different types of hydrocarbons which are there in the mix. All right, so that's why it cannot be considered as a compound, but rather as a mixture. So that's why complex mixture of hydrocarbons is what we see for different petroleum products. All right, so this is how and there are various different types of hydrocarbons. We perhaps don't need to go there, but just as an example, there are some which are called as alkanes, there are some which are called as alkenes, and there are some which are called as alkynes. So you might remember this, you might not remember this, but whatever may be the case, it's not really required from the examination perspective. So just that, only thing that you need to know here is that petroleum is a complex mixture of hydrocarbons. That's it. Now, moving on to the formation of formation of petroleum. Now when it comes to the formation of petroleum, the formation process would have been very similar to the process of formation of coal. What we discussed for coal was that there would have been vegetation growing in the wetlands. Due to either seismic activities or geological activities, they might have gotten submerged under land. And while getting submerged under land, they got mixed with the sediments. And under the conditions of high temperature and high pressure over a long period of time, a chemical conversion of these organic vegetation happened into coal. Something similar happened in case of petroleum as well, that we had these underwater organisms, whether algae or maybe zooplanktons, and these algae and zooplanktons over a period of time, they got submerged under the ocean beds and the sea beds. And this is where we see that they might have gotten mixed with the sediments, again subjected to very high temperature and pressure. And under these conditions, organic conversion here also starts. Now when it comes to this organic conversion into petroleum, we see that there are various intermediate steps that finally led to the formation of petroleum. That initially these organic molecules of plants and animal remains, they first converted into something called as kerogen. All right, they some first converted into something called as kerogen. And after the conversion into kerogen, we see that there is a process called as catagenesis that starts here. There's a process called as catagenesis that starts, and after catagenesis there is another process called as pyrolysis. And this, with pyrolysis, we see that finally uh, uh, conversion into petroleum happens. So the very first thing what we basically see is that the formation might have began with the organic materials. Correct, organic materials, where we are talking about zooplanktons and algae. So these zooplanktons and algae, the zoo, I'm just writing it out here, the basic process, zooplanktons and algae, they basically got buried under sea and ocean or ocean beds. Then after that, once this has happened, they mix with the sediments. All right, mix with sediments, subjected to high temperature and pressure. All right, subjected to high temperature and pressure. Then organic conversion into kerogen happens. So the next process is kerogen, which is, in a manner, you can say that this is an organic sedimentary rock. Organic sedimentary rock. So then after this, a process called as catagenesis takes place. Now, when it comes to the process of catagenesis, I'll tell you what we mean by catagenesis. So catagenesis, so catagenesis, what happens is that any organic molecule, all right, whether it is a plant molecule, animal molecule, or even human beings, we are also organic in nature. All right, largely you can say that we are all organic. We have a lot of carbon. We are made of carbon. Now, these carbon chains that we have in our body, these are very large carbon chains, meaning that there is, even one compound would have 80 to 100 carbon atoms in the chain. So now what happens is that these large carbon atoms or these large carbon chains, they start breaking down, or basically hydrocarbons. So they start breaking down into smaller chains. All right, so large organic chains, they start breaking down into smaller chains, and this breakdown is called as catagenesis. So meaning that you have compounds which have, like, let's say 80 to 100 carbon atoms in the chain, and from there on it starts decreasing or starts breaking down into carbon chains of, let's say, like 20 or 15 carbon atoms in one chain. So this breakdown of large organic molecules into smaller organic molecules is called as catagenesis. All right, so this is called as catagenesis. And then at the end of catagenesis, we see that there is another process called as pyrolysis. Now this pyrolysis basically is the pyrolysis basically what the pyrolysis is a process where what we see is that there is a whenever there is a limited supply of oxygen at high temperature, which leads to some kind of decomposition of the matter, it is called as pyrolysis. So pyrolysis, by definition, we can say that pyrolysis is thermochemical decomposition of material in the absence of oxygen at high temperature. All right, so absence of oxygen, high temperature, when any kind of decomposition happens, it is called as pyrolysis. So after catagenesis, the process of pyrolysis takes place, and this leads to ultimately the formation of petroleum. So that's the whole idea. This is basically the entire process that we have. So terms that we have seen: first, kerogen. So kerogen is nothing but solid organic matter in the sedimentary rocks. Then catagenesis, as we discussed, that this is where organic kerogens into hydrocarbons are broken down, meaning larger to smaller setups or smaller molecules. This catagenesis as a process is also called as cracking. You might have heard cracking of petrol or cracking of petroleum, etc. These kind of terms perhaps you might have come across. So cracking is nothing but catagenesis. All right, not to confuse. Cracking, when applied to petroleum, is called as catagenesis. So that's why, as a process, catagenesis and cracking are not different. The only difference is the special way in which catagenesis is defined in petroleum. Otherwise, cracking is the general word for any kind of breakdown, and catagenesis when the breakdown is used in petroleum. So this is basically what we see. So complex organic molecules, they the long chain hydrocarbons are broken down into simpler molecules such as light hydrocarbons. So this is called as cracking. And then finally, the process of pyrolysis. which is nothing but a thermochemical decomposition of organic material at elevated temperatures in the absence of oxygen or any halogen. Anyone who knows what we mean by halogen? What is this term halogen? What is this term halogen? Anyone? Any idea? Yeah, chlorine, bromine, iodine, perfect. Fluorine, yes. So basically, the group 17 that we have, in that group, everything that we have, the salt form is perfect. So these are called as halogens. So halogens basically fluorine, chlorine, bromine, iodine, astatine, all these basically are called as halogens. So they basically behave very similar to oxygen. They can lead to oxidation. So that's why not only absence of oxygen but also the absence of halogens, both have to be considered. Yes, reacts with everything, reactivity is high. So halogens are light also, that's also perfectly correct. So yes, all of you, I mean, everyone giving small bits of answer, you have perfectly defined everything what I wanted to say. Perfect. So these are the terms that we have. So understand the entire process, that this is the process of formation of petroleum. Now, there is another process called as fractional distillation. Now, understand what's happening here, that petroleum that we have, petroleum here is a mixture, all right? Petroleum here is a mixture of hydrocarbons, correct? This is what we discussed, that it's a mixture of hydrocarbons. So, in this scenario, it being a mixture of hydrocarbons, what we see is that in the crude oil, the petroleum that we are getting, it has all the components of petroleum. It has petrol, it has diesel, it has the jet fuel, it has kerosene, it might have paraffin, it might have asphalt. So there are all these things that might be mixed together. So now, obviously, we can't use crude oil. We need these components of petroleum. We use petrol, we use diesel, but we don't use crude oil as such. So now we need to take away all these components, or basically extract all these components from this mixture in crude oil. This is where the process of fractional distillation is used. So understand what is fractional distillation, but before that, understand what is distillation. How do we define distillation? So distillation is a process that is used to, first you give me the answer, then I'll tell you. When do we use the process of distillation? Yes, correct. So to separate out two liquids, correct? So not only just to separate out two liquids, we use the process of distillation when you have two liquids that can mix in one another. So for example, let's say when you consider, let's say, petrol or oil and water. So what happens? Oil, if you are trying to mix oil and water, they will not mix. Oil will simply float on the surface of water, because oil has very light density and water has a heavier density. So that's why water will settle down at the bottom, and oil will be forming a layer on water, so because of density differences. But they do not mix, their composition is very different. But when it comes to some of the organic molecules, some of the organic liquids can mix very easily in water. So now, once organic liquids have mixed in water, it's very difficult to extract them from there. Even milk, for example, that if you pour some water in milk, it's not easy for you to just separate out water and milk, correct? So all these things we can't really do. So in these kind of scenarios, distillation as a process is used, because with distillation, what we'll do is that we would be able to separate out these two liquids. How exactly do we do that? By simply heating this mixture. That if, let's say, you have a mixture of two liquids, one liquid that maybe boils at 50 degrees Celsius, and then there is another liquid that boils at 100 degrees Celsius. Let's say it's water. So water boils at 100 degrees Celsius. There's another liquid that boils at 50 degrees Celsius. You simply take, you have, let's say, that mixture in the room temperature, like let's say 25 degrees Celsius or 30 degrees Celsius. You start heating it. As you start heating it, this is where both will start getting heated up, and as soon as you cross 50 degrees Celsius, one of these two components will start converting into its vapor form, its gaseous form. So let's say if you are at 60 degrees Celsius or maybe at 70 degrees Celsius, one liquid has completely converted into its gaseous form, and the other liquid, that was water, still in its heated state. So in this manner, the gaseous part could be separated out into a separate vessel. So in this manner, we can separate out these two liquids with the help of distillation. So that's why just remember that distillation is a process to separate two miscible liquids. So when I say miscible liquids, miscible meaning the ones that can mix in one another, separate two miscible liquids, but the liquids should have sufficient difference in their boiling points. All right, the liquid should have, so separate two miscible liquids with sufficient difference in their boiling points. Sufficient difference in their boiling points. So that's why this is what happens in distillation. But if the difference between their boiling points is not sufficient, and when I say sufficient, usually it is 25 degrees Celsius, that if the difference in the boiling points is more than 25 degrees Celsius, then it's easy to use the normal process of distillation, that you simply take that mixture, start heating up, one will evaporate and other will be left. So that distillation process can be used when you have a sufficient difference in their boiling points. But if the difference in the boiling points is not sufficient, let's say it's just 10 degrees or maybe 5 degrees or 15 degrees, then this normal process of distillation can't be used. And this is where we use the process of fractional distillation. All right, this is where we use fractional distillation. So fractional distillation also will be used to separate out all these fluids, but the process will be reversed now. That first we'll take this mixture and we'll just heat it up to a very high temperature that is higher than all the boiling points of all the fractions, all the mixtures that you have. And then you start cooling it down. And as you start cooling it down, this is where you'll see that one by one all these fractions will start separating away. So for example, we have the crude oil. All right, we have the crude oil, and this crude oil will be heated to a very high temperature, and then after that we'll start cooling it down slowly. So when we start cooling it down, what happens is that this is where we'll see that first we'll get the ones which have the highest boiling points. Then after that, as we cool it down, the ones with lower boiling point will also start to convert into their liquid form, and one by one you can separate them out. So diesel, kerosene, petrol, butane, propane, all these fractions one by one will keep getting. So this is what happens with fractional distillation. So distillation will be used when you have two liquids that can completely mix in one another, and fractional distillation will be used when, although these liquids are mixing in one another, but the differences between their boiling points is not very high. And then in that case, the normal heating process of distillation can't be used, and we'll have to use the process of fractional distillation. So this is basically how it works. This is basically how we see the process of fractional distillation works. All right, so I hope that this is clear. Any question from petroleum perspective, whatever we have discussed until now? If you have any doubts, please let me know. Okay, there are some doubts, I think, from the last class also. Lokesh, you have asked what is strap-on motors. So strap-on motors is nothing but a booster. Yesterday only Chandrayaan 3 launch happened. So if you look closely, you'll see that there is that main rocket structure, and then there are small rocket-like structures which bind this launch vehicle all together. So these are called as boosters or strap-on motors to provide additional thrust to the vehicle. I'm not able to take the live class because of my internship, so I study via recorded lectures. So any suggestion from your side? Just make sure that you're regular, because many a times there is we have been here for a very long time. Sometimes we see that there is a slackness that comes in the minds of the students when they are not attending the lectures live, and when they know that, okay, fine, if not today, I can watch it tomorrow, and recorded lectures anyway are available with me. So what we see is, I mean, we have all the data, we have all the analytics, we see that people actually don't watch it, and they leave it for later. And that is the only problem that we have with students, when sometimes we see that there is a kind of slackness that happen. If you can ensure that it doesn't happen with you, it's fine. You can go and watch the recorded lectures of this series as well. Yes, tomorrow never comes, Gulam say. So that's why, I mean, even if, I mean, this goes out to everyone attending the lectures, that uh, if at all, let's say due to one reason or the other, you're not able to attend the live lectures, please ensure, take all the pain possible to ensure that the given lecture of the week is being completed in that week. Otherwise the lectures will keep on happening, one subject will end, the next will begin, and the next will begin, and so on, and you will never get the chance to go back to the previous lecture. So please don't do that. Please let this slackness not come in your preparation at any point of your preparation. This, it becomes easy that you just have everything in with you, and you think that, okay, fine, whenever I want to, I'll study these. So please don't let that happen. Only zooplanktons and algae form petroleum. Then animals, humans, what they form after decomposition? Do they form anything? Generally speaking, see, any organic form that we have, whether humans, animals, or plants which are there on the earth, they would simply decompose. They would decompose into organic matter, and that's it. So why zooplanktons and algae is mainly because we are talking about millions of years back. Almost 250 million years ago, there were certain conditions on the earth which led to this special situation that petroleum could be formed. Otherwise, normally speaking, petroleum formation doesn't happen. Even today, it's not that we don't have algae and zooplanktons, but the petroleum formation doesn't happen today because the conditions are very different. The geological conditions of the earth are very different as compared to what it used to be almost 250 million years back, when the petroleum and natural gas formation had began. So that's the basic difference. Otherwise, any other organic matter today would simply decompose into its organic form. Are you covering the whole syllabus in weekday as you cover in morning and evening batches and as in tablet? Yes, of course. I mean, everywhere the curriculum is the same, syllabus is the same, so coverage is also the same. There's no difference there. Only from one session to another, if there are certain additions or subtractions, some relevance goes away, some new relevant topics come in, and these are small tinkering that we do every time we have a new class. Otherwise, the basic skeleton of the syllabus always remains the same. All right, so let's move on. So we have discussed about coal and petroleum, which are conventional sources of energy and non-renewable sources of energy. After this, we also have shale. Now, the other sources that now we are going to discuss are sources which are non-renewable, but they are also non-conventional, because these are sources that we have only started using over the, let's say, past few decades, maybe last 30, 40 odd years, that we started to commercialize all these different sources. And that's why these are called as non-conventional, but at the same time, they are non-renewable because they have a fixed quantity inside the earth. All right. So shale. Now, when it comes to shale, in case of shale, what we see is that this is an unconventional source of hydrocarbon. Largely, again, here also we see that the large part of this shale will be of methane with small amounts of other hydrocarbons as well, but largely it would be methane. Now, shale, understand what shale is. Just look at this picture. So, what we see is that when we go inside the Earth's crust, there is one layer. All right, there is one layer which is called as the shale layer. All right, there is this layer of rocks. So this black colored region that you see on the board, this black colored region basically is made of shale rocks. All right, these are shale rocks, and these shale rocks, what happens is that these shale rocks, as you look at those shale rocks, ultimately what happens is that we dig a well to these shale rocks, and then after that we start drilling horizontally, right? So we go here, we drill a horizontal well from here on. So now by drilling these horizontal well, what we also do after this is that water with some chemical additives will be sent through this well at very high pressure, and that water at high pressure will cause some kind of fractures or cracks in this layer of rocks, and this is where we get the shale gas from. This is where we start getting the shale gas from. So shale gas basically will be extracted from these kind of sources. All right, shale gas will be extracted from these kind of sources. So we reach the shale rock layer, and there horizontal drilling will be done, and then hydraulic pressure, I mean water at very high pressure, will be sent here, causing some cracks in these rocks, and from there on the gases which are trapped in these rocks, they will be extracted from there. So that becomes the shale gas. Now, why we are saying that shale gas is an unconventional or a non-conventional source of energy is that many a time, for a very long time, of course, we did not even know about the presence of shale. But then US found, for the first time, it was the United States that found the sources of shale, and then they found that US had enormous amount of shale, so much so that US before shale used to be a net importer of energy, and from being net importer of energy, it transformed itself to a net exporter of energy. So it used to just, it could not fulfill all the energy needs that it had. It had to import some energy before the discovery of shale, and as soon as they discovered shale, done. And then they found so much of energy through shale that they even started exporting energy, and this really helped them boost their economy and establish them as one of the leaders in the world economy from this energy perspective as well. So that's why it was a very important discovery for the US. And then there was, you can say, a natural justice that was done, and Russia also found a huge source of shale in the landmass of Russia. So that's why the world was a happy place again, that US also found shale and Russia also found shale. And then after that, we also see that even China found shale. So all the biggest powers of the world, you can say in a manner, they found shale, and that's why world is a happy place. Otherwise, there might have been a lot of heres and theres and fights that might have happened, because one would have had the leverage over the other. But all these countries, they found shale, and shale, the discovery of shale became a very, very important part of their entire energy setup. So that is why shale. Now, when it comes to shale resources in India, there are certain areas that have been marked in India as well, where we have found some sources of shale. This is a map that was published by ONGC. So ONGC had published this particular map. All the areas that are marked in kind of indigo color, these are the areas where uh, proven sources of shale have been found. And in all these orange color areas, these are the areas where we have found potential for shale in India. So that's why all these areas have been marked. Last 10 years, between almost 2011 to 2020-21, ONGC has done extensive research on shale. But by the end of 2021, they also started saying that although they have found shale, they have found good resources of shale all across the country, uh, but they still feel that the sources that we have found are not good enough. These are not comparable in any way to what US or Russia or China, etc., have found. India does have shale, but the quantity is not something that can make us very happy. It's very limited in quantity and maybe not viable commercially. So when we say not viable commercially, understand the meaning of commercial viability. So any source, let's say we found shale, all right, and we start extracting shale perhaps. So if we start extracting shale, we of course are using a lot of energy, lot of machinery, etc. So a lot of energy is used up in extracting this shale. Now let's say you are using 1000 joules of energy in extracting shale, and the shale that you are extracting, it is worth 800 joules of energy. Then what's the point? Then in that case, it's not a source of energy that we can say that it is commercially viable for us, that we can use it commercially. If you are using 1000 joules of energy, my expectation will be to get at least 2000 to 3000 joules of energy. So that extra energy that I'm getting, that's the energy that I'm going to provide to let's say citizens of my country, or to the industries of the country, etc. Correct. So if that's not the case, it's not commercially viable, and hence it's not really usable for us from that perspective. So that's the case. So that although they did find shale resources in India as well, but what ONGC said is that although we have these sources, but these are not very promising sources, and probably commercial exploitation of these sources perhaps will not be possible. So that's the story of shale as it goes in India. Overall, when it comes to some of the issues also when it comes to shale, that it increases our consumption of fresh water. We discussed that when you dig the well, you basically send water at very high pressure through this well, correct? So when that is being done in this particular scenario, what we basically see is that a lot of fresh water is used up, or rather you can say wasted. There are chemical additives also which are added to this water, so that's why that makes water completely unusable. Also, it can add to pollution. It can become potential ground and surface water contamination sites. So that's also a possibility. At the same time, because of the pressure that we are applying and the cracks that we are forming, the fractures that we are producing, this induced seismicity can also lead to some kind of seismic instability, or some kind of earthquake like situation might also occur because of all these conditions that we are producing. So that also is a possibility, and there have been certain instances where very small scale earthquake was felt and the epicenter was seen to be some of these resources. And then there are chances of local impacts as well, because these are newer sources, and all of a sudden if any government across the world, it finds a new source of energy, it's not going to go let go of it, right? And it's going to try and exploit it as much as possible. So for the people, the locals who have been living in these areas for maybe ages, for them it all of a sudden becomes a very uncomfortable position, because there will be a lot of movements of, let's say, trucks and machinery, and the noise and the land pollution, water pollution, air pollution, etc. All that comes with these kind of setups. So that's why for the people who have been living in these areas, perhaps will not be a very good scenario to be in. So that is basically what we see with as an issue with the shale gas extraction. Then after this, we have coal bed methane. Now, coal bed methane, especially in the last couple of years, has started to become important again, because India now also has started investing some money into coal bed methane. We have actually wasted a lot of coal bed methane in the past, but now the government is very keen to extract this coal bed methane and also use it as a source of energy. So what do we mean by coal bed methane? So in case of coal bed methane, what we see is that coal bed methane is the kind of methane that we find in the coal beds. Wherever you do coal mining, wherever you have the mining sites, these all areas very often they have been seen to be good sources of methane as well. That these are the areas which can have methane pockets. So if they have methane pockets, then in that case methane can be extracted from there. So that is what will be, if we extract that methane from these kind of coal pockets, then in that case it is called as coal bed methane. So last year, for example, Government of India has also pledged a sum of money investment that will happen for coal bed methane extraction in India. Otherwise, a lot of methane from these sources have also been wasted in the past, but the government is very keen now to start using coal bed methane. So this is what the story is right now. When you look at the coal bed methane sites, these are the areas. All the yellow colored areas that you see in marked in this map, these yellow colored areas, these are the areas where coal bed methane blocks have been awarded in India. So that's why there are these areas where coal bed methane has been found, and that's why we are trying to make sure that we can extract coal bed methane from these kind of areas. Now, one more source that has been in the news is methane hydrate. Now, when we say methane hydrate, what we mean by hydrate is basically that it's a mixture, or in this methane, there is molecule of water, that there is a water molecule, crystalline water molecule structure that is mixed. All right. So this is crystalline water molecule. All right, crystalline water molecule. So crystalline water molecule meaning, see, just understand this, that even at room temperature, it's not always necessary that if you have water, it will always be in a liquid state. There are some of the chemicals that we use in our day-to-day lives as well, which actually are crystalline forms of water without us understanding that that's the case. Simple, simple example is your washing powder. So washing powder is basically sodium carbonate, and then from with sodium carbonate we see that water molecules are also mixed in it. So it's a crystalline form of water molecule. So normally it is in solid state. Unless you mix it in water, it very quickly dissolves in water, but otherwise it has crystalline forms of water molecules as well. That leads to the kind of moisture that they have, but they will not be in a liquid state. So it's not always necessary that wherever you have a hydrate or wherever you have water molecules, they should be in a liquid state at room temperature. Not necessary. All right. So in case of methane hydrate, we are saying that it's a crystalline form of methane and water. It looks something like this. Now, when it comes to this methane hydrate, we have seen that there are various parts of the world where we have found deposits of methane hydrates. So, for example, if you look at the map above, what you see basically is that all these orange colored areas that are marked in the map, these are the areas where methane hydrates have been found. So methane hydrates, that's why all the continental margins, as you can see, all the continental margins, the Arctic and the Antarctic areas, and deep sea and deep ocean and lake beds, these are the areas where deposits of methane hydrates have been found. So sediments and sedimentary rock units below Arctic permafrost, sedimentary deposits along continental margins, and deep water sediments of inland lakes and seas under the Antarctic ice. So these are the areas. So again, Arctic and the Antarctic ice, continental margins, and the deep water sediments of inland lakes and seas. So these are the areas where we have found the deposits of coal bed methane. Sorry, the deposits of methane hydrate. Now, when it comes to methane hydrate, there is one very important concept related to methane hydrate, and this is what I want to uh, discuss with you, but through this question. This question was actually asked in your paper, and this question actually is about a very important topic. So please read the question first, and then let me discuss this with you about what the answer should be for this particular question. I'm also launching the poll for you, so if you have read the question, please mark your answer as well. Please mark your answers once you have read the question. So it's kind of a mixed bag that we have here: 42% A, 25% B, 17% C, and 17% D. Let me discuss this question. All right. Which of the following statements are correct about the deposits of methane hydrate? First is global warming might trigger the release of methane gas from these deposits. This is correct. So the problem that I wanted to discuss is mainly about climate change. Now, what we basically see is we discuss that Arctic and the Antarctic areas, correct? Both the areas have methane hydrates. Now, we know that with climate change, with global warming, the polar ice caps are melting. Now, the methane deposits that was buried deep under the ice. Now, what happens is that this ice is starting to melt, and with the melting of ice, this methane now comes to the surface, and then simply can exit and mix with the atmosphere, correct? So then in that case what happens is that because of climate change, because of global warming, methane is actually going and mixing with the atmosphere. So that's why global warming might trigger the release of methane gas from these deposits is correct. And that's why, in a manner, what we basically say is that global warming is leading to more of global warming, right? That global warming is accelerating global warming. So that is a very worrisome situation here. That because of this, what we basically are seeing is that global warming accelerates global warming. Accelerates global warming. So this is basically what we see. So that is why first is correct, that this is fine. Second is large deposits of methane hydrate are found in Arctic tundra and under the seafloor. This is correct. We discussed Arctic, Antarctic, seafloor, and continental margins. Correct. These are the four areas. So that's why this is also correct. Third statement is methane in the atmosphere oxidizes to carbon dioxide after a decade or two. Is this correct or wrong? This is also correct. The chemical conversion happens something like this, that you have methane that reacts with oxygen, forming carbon dioxide and releasing moisture. So this is the chemical equation of what happens. And if you are also a fan of balancing the equations as I am, so this becomes 2H2O and this becomes 2. So this is the balanced equation. So I really can't live without balancing the equation. So fine. So this is the chemical conversion that happens. Now understand this, that methane by its very nature is not very highly reactive. All right. So it's not that it will just quickly react with anything and it will convert into something else. That doesn't really happen very quickly with methane. So methane will take a lot of time before it will start reacting with oxygen that we have in our atmosphere. So methane then will react with oxygen and then it will lead to the formation of carbon dioxide. Usually we see that a process like this can take up to 8 to 12 years. A process like this can take 8 to 12 years, and hence we see that this is the example of what happens. And yes, that's why this is also correct, that methane in the atmosphere oxidizes to carbon dioxide after a decade or two. Now this is one very problematic situation altogether, because when it comes to methane, and with global warming, what we see is that more methane is getting released into the atmosphere. Methane as a greenhouse gas is much more potent as compared to carbon dioxide. So as compared to carbon dioxide, it is much more dangerous for us. If let's say we are looking at a 1 year period, it is at least up to 20 to 25 times more dangerous as compared to carbon dioxide. It actually can cause much more a greenhouse effect as compared to carbon dioxide. The problem that we have is the volume with which we emit carbon dioxide as compared to methane. So that's why carbon dioxide is the bigger challenge for us. Otherwise, if it was, let's say, between 1 kg of methane and 1 kg of carbon dioxide, I would always choose 1 kg of carbon dioxide. 1 kg of carbon dioxide will be lesser of a devil as compared to 1 kg of methane. So that's why methane is much more dangerous as a greenhouse gas as compared to even carbon dioxide. All right. So all these three statements given here, all these three statements are correct. So this is what I wanted to discuss. But since the question has been asked, I thought that let's discuss this with the question itself. Right. So this is what we see with methane hydrate. Then again, one more source that we have is HCNG, called as hydrogen enriched compressed natural gas. Now, in case of HCNG, what we basically see is that this is where CNG is being mixed with hydrogen. Now, first and foremost, what is CNG? CNG is compressed natural gas. Now, whenever you see the term natural gas anywhere, just remember that we are talking about nothing but methane. Natural gas in its composition has almost 85 to 90% methane, and then rest 10 to 15% could be carbon dioxide, other hydrocarbons, all these things just mixed together. All right. So that is what we see in methane, or rather in natural gas. So when we say compressed natural gas, it means that we have compressed this. We have compressed it to a very small scale so that it can be used. And this CNG is something that we use as a fuel. It can act as a replacement of petrol or diesel or even LPG for that matter. So compressed natural gas. Here we are talking about hydrogen enriched compressed natural gas, HCNG. So we are basically adding hydrogen to HCNG, hydrogen to CNG. Now, why hydrogen? Today, when you look around the world, you'll see that there is so much of emphasis on hydrogen. Even India, for example, we now have a national green hydrogen mission. Now, when it comes to the National Green Hydrogen Mission, we are basically looking up to scale up the process of hydrogen manufacturing so that we can use hydrogen in various different ways, in various different forms of fuel. So, why we are chasing this hydrogen? Why not only India, but rather the entire world has been chasing hydrogen? Understand the advantages that hydrogen brings in. First advantage that hydrogen has is its efficiency. That hydrogen is very efficient, that with small amount of hydrogen we can produce a large amount of energy as compared to any other source. So that's why efficiency becomes a very important factor when we talk about the advantages that hydrogen brings in. So that's why efficiency is one very important point. Then at the same time, we also see that it is a clean source of fuel. Correct. We are mixing it with CNG. CNG has methane, which while burning, while the combustion happens, will convert into carbon dioxide. So some pollutants will be released into the atmosphere. So to reduce all these pollutants, especially carbon dioxide and other greenhouse gases, hydrogen being mixed, hydrogen is completely clean, so it will not add to the pollution problem. So that's why it makes the entire fuel, even CNG, although CNG is relatively cleaner as compared to petrol or diesel or even LPG for that matter, but still we can bring down the pollution level with the help of hydrogen. So hydrogen is efficient, hydrogen is clean, and hydrogen is abundant. Hydrogen is abundant. So now when we say hydrogen is abundant, what we basically mean is that first and foremost, even if you look at the elemental form, hydrogen is the 10th most abundant element in the earth or in the earth's atmosphere. But forget about just the elemental form of hydrogen. Look around you, and there are so many organic molecules, so many hydrocarbons from where hydrogen can be extracted. From water also we can extract hydrogen, which is the process that is called as electrolysis. So there are multiple processes and there are multiple such sources that in one form or the other have hydrogen mixed in them. So that's why hydrogen is abundant. So hydrogen is abundant, hydrogen is clean, hydrogen is efficient, and you can say that hydrogen is also renewable. Hydrogen can be counted as renewable. Why are we saying this? Because you'll see, and we'll discuss some of the processes where you'll find that more and more hydrogen can be brought back after the combustion has happened. So that's why hydrogen has all these qualities, because of which right now we have been chasing hydrogen in any way possible, whether it is HCNG, whether it is hydrogen fuel, whether it is fuel cell, whatever be the form, or even nuclear fusion, for example. Whatever be the form, in one way or the other, we are trying to make the best use of hydrogen availability on the earth. So that's why hydrogen. So advantages that HCNG will have is, first and foremost, it reduces emissions of carbon monoxide, enables fuel saving. Engines can be calibrated to release lower amount of nitric oxides. Then engines need minimum modification to run on HCNG, and this is very important as well, that all the CNG engines with very small modifications can start running on HCNG fuel as well. So it's not that you need a completely new infrastructure because it's a completely new fuel. That's not the case. So that's a very important advantage. And then after that, it's also an ideal fuel for high load applications and heavy duty vehicles. So normally for these kind of vehicles, we often see that diesel or maybe petrol is used in certain cases. So in this case, HCNG can also become useful, although normal CNG is not useful for very heavy load applications, but HCNG would be. So even trucks and buses can run on HCNG. So that's a very important point. And then better performance due to high octane rating. So basically we are talking about a better efficiency, that it has a better efficiency and very less amount of pollution, or almost, let's say, negligible pollution. So these are some of the advantages that we have when it comes to HCNG. But there are certain issues. The issues, first of all, determining the most optimized hydrogen to natural gas ratio is very difficult. But it's not that it's impossible. We already have used HCNG. For example, there was a pilot project that was run in Delhi a couple of years back. And in this pilot project, they have used HCNG in the buses to just understand the commercial viability of the entire project, and the stability of the engine, and how good or bad the performance is. So we are just trying to understand each and every aspect, and then after that perhaps we'll see that we'll understand the optimized ratio of hydrogen to natural gas. But otherwise what happens is that hydrogen to natural gas, determining the optimized ratio is difficult. So that's why even the project that we have run in Delhi, we after running it for like 6 7 months, we have stopped it, and we are looking at the studies, we are looking at the data, and perhaps based on this study and data, there will be new developments that will also happen here. All right, so determining the most optimized hydrogen to natural gas ratio is also difficult, requires new infrastructure for preparing HCNG, correct? So the investments are higher in this scenario. So you are using a lot of money. So that's why these investments can also be a tricky situation. And commercializing at a large scale, before doing that, there are multiple steps and setup that we have to do. So that also is missing right now. And the next problem, and one of the biggest challenges right now, is the cost of hydrogen extraction is very high. So because of that, obviously if you are getting HCNG from that extract, it also means that HCNG is also going to be very costly. So that's why for the buses running, let's say if you want to run public buses, you if you want to run the public bus with HCNG, then in that case, for running those buses, you first have to ensure that the quality is up to the mark, there is no issue whatsoever, and the cost can also be reduced, that also cost can also be optimized, so that people at large can use it. Otherwise what happens is that people may not want to use it. If you just simply say that okay fine, because this is environmentally friendly, so now you start paying higher. The people who are traveling in the public transport in the buses are also doing because of the fact that they want to save money, and it might even hamper their budget if they start paying more just because it was HCNG. So for me or for you sitting in a classroom talking about ideal situations in science and technology and environment, it might seem that yes, let people pay more, but understand from the perspective of those people whose daily budgets are dependent on how much they are paying on the bus. So for them it's not going to be easy to adopt this and simply understand the problem. Look at this question. This question was asked in your paper. Please read it. Meanwhile, I'll launch the poll for you. It's an easy question, I would say, but still. All right. So as I three, many of you have marked the answer. Although I see that it's distributed again. 22% have said A, 30% B, 13% C, and 35% D. Now, D, I'm not sure. It was very easy to eliminate C and D. In the context of proposals to the use of hydrogen enriched CNG, HCNG as a fuel for buses in public transport, consider the following statements. First, the main advantage of the use of HCNG is the elimination of carbon monoxide emission. Now, this is where many a times UPSC also traps you. What we, if I let me just go back, the advantages what we discussed is that HCNG reduces the emission. Here it says elimination. What is the meaning of elimination? Elimination means that you have completely taken it away. So we are saying reduction, we are not saying elimination. So just because of elimination, this answer or this option, this statement is not correct. All right. So it's not elimination, it is reduction. So these kind of small mistakes many a times happen, that you already see that, okay, fine, reduction in carbon monoxide happens. Here the word was elimination, and we tend to overlook these kind of words, which can also lead to wrong answers. So that's why one can't be correct. So if one is gone, A is gone, and D is gone. Then look at the fourth statement, because now one is 2 and 3 and another one is 4. So either 2 and 3 are correct or 4 is correct. So let's look at 4. HCNG makes the fuel less expensive than CNG. Is it possible? Is it possible that HCNG will be less expensive than CNG? We just discussed that because of hydrogen, the cost of CNG will rise, because hydrogen cost or manufacturing of hydrogen cost is at a higher state. So that's why obviously it can't be less expensive, it will be more expensive. So that's why C is also gone, and the answer will be B, 2 and 3 only. So HCNG as a fuel reduces carbon dioxide and hydrocarbon emission. Of course, that's why we are using it. And hydrogen up to 1/5 by volume can be blended with CNG as fuel for buses. Now, this is a difficult statement. I would simply say that this was a difficult statement if, let's say, the elimination did not work. Because here the elimination works, so we can get to the answer that, okay, without even knowing whether 2 and 3 are correct, we still have been able to get to the answer. But that may not be considered may not be possible considering the new pattern of paper that has started coming in the last couple of years, especially the one that we saw this year. But the answer here will be B, 2 and 3 only. So if there is any question that anyone has, any question from whatever we have discussed? How HCNG reduces emissions of carbon monoxide? So basically what happens is that in case of carbon monoxide will always be released whenever you have any kind of hydrocarbon. So if the combustion of hydrocarbons is happening, combustion of any organic molecule is happening, then in that case there are chances that carbon monoxide will be released. But in this case, when you have added hydrogen, it also means that you have reduced CNG. So because you have added hydrogen, let's say even if it is 20% hydrogen, it means that at least from 100% CNG, now it is 80% CNG. So that's why there will be a reduction in carbon monoxide emission. What is octane rating? Octane rating basically is the rating that determines the purity of the fuel and at the same time the efficiency. It adds to the efficiency of the fuel and the combustion nature of the fuel. So that is what we see with octane rating, that if there is any fuel that has a high octane rating, then in that case it will be considered to be better as a fuel. If methane is that much dangerous to the environment, then why governments are promoting the use of CNG? You will get this answer a little later. I'll discuss this when it comes to biogas discussion. Oh, okay. Let me tell you a very simple thing. We'll anyway discuss that later as well. That when it comes to CNG or any source that uses methane as a fuel, understand the difference between releasing methane directly into the atmosphere versus the combustion of methane. Because when combustion of methane happens, because if we are using it as a fuel, it simply means that this is about combustion of methane. So when combustion of methane happens, combustion of methane simply means that it is being oxidized. Correct? Any combustion happens in the absence of, sorry, in the presence of oxygen. So this is basically also a very similar situation. So in this particular scenario also, what we see is that it's not methane that is released into the atmosphere, but it is carbon dioxide. So although carbon dioxide is also a greenhouse gas, but as we had just discussed that it is much less harmful as a greenhouse gas as compared to methane. So if let's say the same methane was directly getting emitted into the atmosphere, that will be very dangerous. But when you are using methane and when you are, let's say, eliminating any chance of direct uh, emission of methane, that actually is better from this perspective. I hope that I've cleared your doubt. Do we get hydrogen only from atmosphere? No, absolutely not. We can get it from water. We can get it from many of the hydrocarbons as well, petroleum products as well. Even from coal, we can get hydrogen. Even from nuclear energy sources, also we can get hydrogen. So there are multiple different ways in which hydrogen extraction can happen. So it's not that we get hydrogen directly from the atmosphere always. Please mention current affairs also related to HCNG. So right now the biggest news is this only, that in Delhi we ran some 50-60 odd buses with HCNG as a pilot project that now has concluded, and depending on the findings that we have from there, we perhaps will take a decision for the future of HCNG. Can you please explain CBD? So CBD is coal bed methane. So sorry, no, acha, CBM, I thought you were asked. Can you tell me what is the full form of CBD that you are asking here? Anyway, so all right. So whenever that is posted, I'll take your question. So this is basically the end of the first part, which was basically about all the non-renewable sources of energy, where we have discussed coal, petroleum, and all the other unconventional or non-conventional sources of energy. The next set of energy sources are all the energy sources which are renewable in nature. Now, going to renewable energy sources, first energy source for us is solar energy. Okay, it is coal bed methane only that you asked. So coal bed methane is nothing but methane that we are getting from the coal beds, from the areas where you have coal. When you extract methane from there, we often see that wherever you have the coal mining areas, coal reserves, it has pockets of methane that can also be extracted and used as a fuel. So that is what is called as coal bed methane. All right, so before going into solar energy, uh, we have completed one part. Let's take a very small break. I don't want to take a big break right now. It's 3:80, sorry, 1:18 p.m. that I see. Let's be back by 1:25 p.m. I'm not taking a lunch break right now. We'll take lunch break after solar energy, maybe somewhere around 2:15. Somewhere around 2:15, we'll take the lunch break. Right now, let's take a very small break and let's be back. Welcome back, everyone. Now we move into renewable energy sources. Now, when it comes to the renewable energy sources, the most important renewable energy source perhaps is solar energy. And when it comes to solar energy, why it becomes such an important energy source for us is also because of the fact that this is a freely available source of energy. And that's why we see that there is an immense potential that we have in tapping this solar energy. Also, added to the advantage is also the fact that India, you can say in a manner, is also a tropical country. Tropic of Cancer, you know that it passes through India. So at least one half of the country is uh, has a better intensity of solar energy. So that also adds to the advantage that India has, and hence India can use solar energy very well. So this is something that we also understand. And but not only solar energy, we have been trying to set up the various different forms of energy as well. So for example, we have been working very hard in establishing our infrastructure with wind energy too. We have been working hard in establishing our biofuels as well. And then after that, very often, very recently, we have also taken hydrogen as a fuel as well, and we want to work on it. So that's why there are all these resources that we want to work with. Now, overall, let me first tell you where we are with regards to everything renewable. First and foremost, we had taken a pledge, or we had kept our own targets for renewable energy sources in the Paris Climate Summit. In the Paris Climate Summit, we had announced that by 2022, we will have a setup or installed capacity of 175 gigawatt. All right, a setup of 175 gigawatt. So, a total of 175 gigawatt by 2022. This was the target that initially we had taken. Out of this 175 gigawatt, there was a distribution that India started working on. That out of this 175 gigawatt, 100 gigawatt would come from solar energy, 60 gigawatt would come from wind energy, 10 gigawatt would come from biofuels, and last 5 gigawatt from small hydroelectricity power plants. So this is the target that we had kept for 2022. Now, out of this target, since now we already are in 2023, out of these targets, in solar energy, we were able to reach approximately 63 gigawatt by 2022. In wind energy, almost 42.5 gigawatt. Biofuels where we have been able to exceed that over the targets, and here 10.7 gigawatt is where we are. And in case of small hydroelectricity, also almost we had reached the targets of we were at almost 4.9 gigawatt. Now, overall, this is the present scenario, not the present scenario, but rather the end of 2022 scenario. All right. The next target that we have taken, the next target that India has pledged is for 2030. And in 2030, we are trying to broaden our horizon with regards to all the renewable energy sources. So in 2030, the target that we have is of 500 gigawatt. 2030. All right. So this we are talking, not to confuse, this is renewable energy targets. All right, renewable energy targets. So 2022, this was the case. Now for 2030, our target now is one has increased a lot, and this is now 500 gigawatt. Now, when it comes to this target, this time we see that there are various different sources that have been added. So, for example, in this 500 mix, we will be counting solar energy again, estimated to be around 300 gigawatt. We are counting wind energy also. And here estimated to be around 150 gigawatt target is being kept. And then after that, we have biofuels again. And for biofuels, this time the target would be 30 gigawatt. But apart from that, this time we see that there are newer targets also being taken. There are newer sources also which are being added. Now, out of these newer sources, so first the older sources, of course, with regards to the small hydroelectricity as well. So small hydro will also, of course, be a part of it. Small hydroelectricity will also be a part of it. And this time estimates will be around 10 gigawatt. But now we add new sources as well. What are these new sources? This time we are also talking about hydrogen. We also want to build an infrastructure for hydrogen for almost 125 gigawatt. Apart from that, they are also including nuclear energy also in this setup. This time approximately for 10 gigawatt. So even nuclear energy should be considered. And then there are other smaller energy sources as well. For example, geothermal energy, ocean energy, tidal energy. All these energy sources also will be working on. So, but these all sources will not be a big contributor to this entire setup. Now, you might say that my calculations are off, that on one hand I've written 500, and this entire, somebody if does the calculation would simply say that this is going beyond 500. So this is just a rough estimate of where we might stand. Some of the government reports, some of the international reports, they have suggested that this is where India might be. There are certain things that we have taken the targets for, and there are certain estimates that we have made. So that's why this is the setup that we basically would be targeting for 2030. So that's why 2030 will be very, very important from this perspective, that we are adding all these newer sources as well. Now, coming to solar energy, the most important one, because as you can see here, that solar energy takes the biggest chunk out of the entire energy targets that we have. So that's why, of course, solar energy becomes extremely important for the examination. Now, when it comes to solar energy, of course, we are talking about the energy that is obtained from the sun, which is called as solar energy. And this solar energy is incident on the earth all the time, every day. And this is the energy that we want to extract. Now, this energy can be utilized in two forms, either as heat or its radiation or light. If we are using the heat of the sun as one of the applications in any kind of application, then in that case, it is called as solar thermal energy. All right, it is called as solar thermal energy. So thermal basically comes from the word therm, and therm, the word means heat. So that's why whenever we are utilizing the heat of the sun for any kind of application, we would say that this is solar thermal. On the other hand, we have solar photovoltaic. So, so if it comes to solar thermal, for example, so solar thermal means that we are talking about heat of the sun. So, for example, let's say solar cooker or solar water heater. All these sources, they can be said to be solar thermal. On the other hand, we have solar photovoltaic. Now, again, when we look at the word photovoltaic, photo basically signifies light, photo signifies light, and voltaic signifies electricity. Photo signifies light and voltaic signifies electricity, meaning that when we are using the solar light, when we are using the sunlight for extraction of energy, for extraction of electricity, then in that case, we'll say that this is solar photovoltaic. So normally here, for example, we have the solar panels, and these solar panels will be used to provide energy or provide electricity. So then hence we'll say that solar photovoltaic basically is nothing but the use of solar panels to generate electricity. Now, electricity generation although happens through solar photovoltaic largely all across the world, but even there are cases where even the heat of the sun is being used to utilize, to generate electricity. So, for example, in Israel, they have been working on a plant, and this plant basically a power plant basically. So this power plant will have huge storage of water, and the sunlight which is incident on the earth, the sunlight will be concentrated towards this body of water, heating this body of water, generating steam from here, and this steam will be used to rotate the turbine, and from there on generate the electricity, just how we saw the case of Rankine cycle in coal fired thermal power plant. So a very similar process, just that this time you are heating water with the help of concentrating with large mirrors, etc., large lenses, and you are trying to focus all the solar energy into the body of water, heating the body of water. So that is also something that they have been doing. So solar thermal generally means when you are using the heat of the sun, whether solar cooker, solar water heater, or even these kind of electricity production units, or then solar photovoltaic, where we are using solar panels for generation of electricity. Now, when it comes to solar panel, what we see with solar panel is that solar panel would convert the solar energy into electricity. All right, it will convert solar energy into electricity. Now, why basically this becomes very important is because we see that there are various different applications for which we can make the use of uh, this solar panel, and today that's why we see that this solar panel is used widely for the production of or other generation of electricity. How exactly does it do it? It does it with the help of something called as a semiconductor. So when we say semiconductor, it simply means that it is neither completely a conductor and nor completely an insulator, and that's why we are saying that this is a semiconductor. So why exactly are we saying this, and how does it get its properties? Why is it being called as a semiconductor? Because there are only certain conditions under which such a substance would act as a conductor, otherwise it will act as a non-conductor or an insulator. So in this case of a solar panel, we use the same semiconductors. For example, silicon. Silicon is a very well-known semiconductor, and this silicon can be used in making the solar panels. So now what basically happens is that when light strikes silicon semiconductor, it causes electrons to flow and thereby produce electricity. So this is basically what we see. So what happens is that if you look at, sorry, if you look at this working of the solar panel, so what we basically see is that when the sunlight is incident on the solar panel, what it does is that let's say we have a solar cell or a solar panel like this. So initially, suppose it has all these electrons, and electrons are just randomly arranged, correct? These electrons are randomly arranged. Now sunlight falls on this. Sunlight falls on this semiconductor, and when sunlight falls on this semiconductor, we see that all these electrons, they get aligned. All these electrons, they get aligned in a particular direction, and this leads to the flow of charge. This leads to the flow of charge. So meaning that when sunlight photons or the particles of sunlight, when they hit the surface of the semiconductor, they help in the unidirectional arrangement of electrons, which leads to the flow of charge through the semiconductor, and hence electricity is generated. So I'll just write it down here for you so that you can use it in your revision. So when solar photons or solar particles basically, or particles, strike the semiconductor, the electrons inside the semiconductor get arranged in a unidirectional fashion, leading to generation of electricity. All right. So this is basically what we would see in this particular scenario. So now overall what happens is that these semiconductors hence can be used. The kind of, when it comes to this unidirectional flow of electricity, the kind of current that is produced is called as DC, direct current. So this direct current then also can be converted into something called as an alternating current with the help of an inverter. So you might have used inverters in your homes, and these inverters, what do they do? That whenever electricity supply is cut off, there is no electricity, the inverters will start working and you would have electricity supply. Correct. So now in this particular scenario, uh, what we basically see is that so in this particular scenario, what we see is that this direct current, if we want, we can use it. All right. So direct current is the kind of current or kind of electricity that can be stored. The one that can be stored. So the one that can be stored is called as direct current. So let's say any kind of battery, whether it is your mobile phone battery, a laptop battery, or any kind of battery that we are using, the kind of electricity that it has, it is called as direct current. And alternating current is the kind of electricity that provides electricity to our homes. So that is called as alternating current. So the role of the inverter is to uh, convert the direct current into alternating current. So that's why the inverters, if you have inverters at your home, you'll see that it will be attached to a battery, and that battery keeps getting charged all the time. And once the battery is completely charged, if at all electricity supply is cut off, then this battery would take over, and it would start uh, sending energy through the inverter, and inverter will convert this direct current into alternating current. So we can use this solar energy in both the cases, that either we can use the inverter to convert this electricity into alternating current, and then from there on just supply it wherever we want. And when it comes to direct current, even if we want, we can do that as well. So in this manner we see that solar panels work, and solar panels will be used in various different setups while we are working with them. Now overall, one more very important component with solar energy is solar pump. And over the last few years, we have seen that there has been a lot of emphasis that has been put on solar pumps. So what are solar pumps? How exactly do the solar pumps work? Let's try to understand that. And why are we saying that it has become very important? In 2019, there was a scheme that was launched by the government of India called as the PM Kusum scheme. In 2019, this scheme was launched. Now, this PM Kusum scheme, and again, this was supposed to run from 2019 to 22, and this year in 2023, they have started phase two of this PM Kusum scheme. All right, phase two of the scheme now has been started. So they started with the first phase, and now the second phase is where we are. So now when it comes to the PM Kusum scheme, the basic idea about PM Kusum scheme is to replace the coal petroleum based energy wherever we are using with uh, solar energy or others as much as possible. In this scenario, the most important job that has been taken by the PM Kusum scheme is solarization of agricultural farms. Solarization of agricultural farms and replacement of the diesel pumps with solar pumps. All right. So there are two basic things. One, solarization of agricultural farms, and replacement of diesel with solar pumps. All right. So replacement of diesel with solar pumps. So these are the two major things that have been taken as objectives as a part of the PM Kusum scheme. Now, because of that, solar pumps become important. So just understand a few basics about the solar pumps. So solar pumps either on the basis of the pumping system, they can be either classified into direct and alternating current based motor pumping systems. So in all these cases, depending on what kind of energy requirements we have, we can use the DC or the AC motor. Then after that, if we are, especially if we are using the AC motor, the AC motor system will require an inverter so that the direct current can be converted into alternating current. The most important and the most common way to classify solar pumps is on the basis of where the installation of the pump is being done. If the installation of the pump is being done uh, inside the body of water, all right, if it is being done inside the body of water, then in that case it's called as submersible pump. If at all it is being done near the body of water, it is called as surface pump, meaning submersible pump will be placed in the body of water and surface pump will be kept next to or near the body of water. So this is basically what we will see. Now in all these cases, what we understand is that when it comes to the pumping mechanism, if we, let's say, have a tube well or any kind of well, mostly a stagnant source of water, we generally prefer a submersible pump there. That there will be a pump and solar panel will be attached right next to it. If normally if we have a flowing body of water, then in that case we prefer surface pump, and surface pump will be placed near the body of water, right next to the body of water, and try to extract water from there. So that's why this is the most common way in which we classify what the pumps are. So that's why these are submersible and surface pumps. The next way to classify the pumps is on the basis of what is the technology being used to extract water. On the basis of this technology, we have centrifugal pump and positive displacement pump. So centrifugal pump is the pump that is using centrifugal force, and hence the name centrifugal pump has been given. So centrifugal pump is the kind of pump that is using centrifugal force. How exactly? Centrifugal force is the force that acts in a circular motion. And when the rotation of motor happens, so just imagine that you have a body of water and you have the motor inside, and the motor starts rotating. So as the motor starts rotating, it will start throwing the water outward, correct? It will start throwing the water outward. This is called as centrifugal pump. That you will be in the body of water, the motor will be working, and the motor will keep on throwing water outside. So that's why this is called as centrifugal pump, because we are using centrifugal force for this pumping mechanism. So that's why centrifugal. Now the second one is the positive displacement pump. Now when it comes to positive displacement pump more or less works like an injection. All right, it more or less works like an injection. How exactly you use an injection? That, let's say if you have a vaccine bottle, you'll see that injection will be inserted inside, and then they will start pulling the piston. And as they pull the piston of the injection, you'll see that the there will be a rise in the level of vaccine. Similarly, even if, let's say, blood is being extracted with the help of injection, you'll see that once they start pulling the injection, the blood will be pulled out. So this is very basically when the piston is pulled, and pulling the piston creates a pressure difference. And because of this pressure difference created because of pulling of the piston, we see that the water or the liquid level will start to rise. So this is the scenario in positive displacement pumps. So usually what we see is that centrifugal pumps will be submersible and positive displacement pumps can be surface pumps. So that, although it's not an hard and fast rule, But generally speaking, we see that these kind of combinations are made. So that's called as centrifugal and positive displacement pumps. So centrifugal pump, basically it works on the principle of centrifugal force. And when it comes to the positive displacement pumps, we see that these pumps will have a higher frictional forces than the centrifugal pump because of the contact. So this is one very very important point, because there is a contact that is happening with the surface all across. So that's why that will increase the energy dissipation happening in this kind of a scenario. So that's why we see that because of this, the positive displacement pump will be used in this fashion, and overall there will be a piston or a cylinder that will be used, which will try to pull the water up. So this is another way of classifying. There's one simple question that was asked in your paper with respect to this particular topic in 2020. Just read the question once, and then I'll launch the poll for you as well. But first read it. There are two statements. I'm launching the poll for you. Please mark your answers. I see that some of you have posted some questions as well. I'll take the questions at the end of this topic, all right? When we complete solar energy, I'll take all your questions. Wonderful to see. Almost 70% of you have given the correct answer. That is D. Let me read the question for you. With reference to solar pumps, consider the following statements. Solar power can be used for running surface pumps. This is correct. Not for submersible pumps. That's not correct. We just discussed that we can use some submersible pump as well. So that's why this is wrong. The second statement says solar power can be used for running centrifugal pumps. This is also correct. And not the ones with piston. That's wrong, because positive displacement pumps have the piston. Correct. This is a feature of the positive displacement pump. So that's why this second statement is also wrong, because here also this is wrong. So correct answer, that's why, will be D, neither one nor two. Now, many times I know also what happens, that when you read a new question which looks to be a little unfamiliar altogether, it's a general tendency for us to think that at least one answer or at least one statement should be correct. How is it possible that none of the statements are correct? And this is something that was unique with especially 2020 paper. In 2020 paper, there were a lot of answers that were D, especially in science. A lot of answers were D. So even for us, it got confusing when we started solving the paper, that how is it possible that every answer is either none of the above or all of the above. So even our confidences were also shaken. So that's why this is also a possibility that can often happen with many of you also, that you might not be able to comprehend why, how is it even possible that all the statements are wrong. But just remember this, that there, whenever you read any statement about any MCQ, you always have to take that statement on its merit. Just read that statement independently, without having any notions, any assumptions in mind, and just try to understand what that sentence is. So that's why please make sure that this becomes a part of your habit altogether. So here the answer will be neither one nor two. Now next, we have an important topic, and this is National Solar Mission. Now, when it comes to National Solar Mission, this is a mission as per which there is a target that has been taken. The target was 100 gigawatt by 2022. So 100 gigawatt by 2022 was the target that was taken as a part of the National Solar Mission. And this target that we had kept was a very steep target, because initially when we started with this mission had a target of 20 gigawatt. This mission had a target of 20 gigawatt, and then we revised this target of 20 gigawatt to 100 gigawatt in 2015. So that's why it was a very steep target that we took for ourselves, but thankfully so we have been able to do a very good job with regards to the where we are right now. Now, of course, there are two ways to look at it. You might also feel that, okay, 100 was the target, we are at 63.5 approximately. So, how is it a good setup? At the same time, I could also argue that initial target was just 20, but we have been able to achieve 63.5, which is a remarkable job. So, that's why, again, there are different perspectives on it. But remember this, that any renewable source that we are discussing, it's not easy to set up the infrastructure of renewable energy, whether solar energy, wind energy, biofuels, anything that we are going to discuss. It's not easy to maintain their setup or even set up the infrastructure on the first hand. So that's why it's not that easy that we can keep a very steep target and we'll be able to achieve it. But still, that's why I'm saying that I would still say that it is a remarkable job that even we could reach up to 60-65%. So this is the National Solar Mission. Now, objective, of course, is to establish India as a global leader in solar energy by creating the policy conditions for its diffusion across the country as quickly as possible. Now, in this scenario also, when it comes to the National Solar Mission, there are these four aims that were a part of the National Solar Mission. First, to take long term policy so that solar energy is not something that we are only uh, working on aggressively today, but it should be a long term policy of how we can better utilize solar energy tomorrow, and we can make both qualitative and quantitative improvements in solar energy. Then large scale deployment goals, aggressive research and development. So large scale deployment goals mean that everywhere we want to start using solar energy, and aggressive research and development needs to happen in this field so that we can keep improving, we can keep innovating. Now, the last point that you have here, the domestic production of critical raw material and components and products. So what we basically see is domestic production is what we are emphasizing on. Now, initially you will see that a lot of solar panels that India has been using, solar panels, they basically uh, these solar panels are often imported, or they were being imported a lot, and US used to be the biggest market that used to export solar panels to India. Now India all of a sudden revised the targets from 20 gigawatt of target, we climbed up to 100 gigawatt of target. So we also understood that it's not that easy for us to work with these targets and achieve the goals if we are just dependent on imports. That it cannot be only imports that bring us to the target. So that's why this is where we also thought that, okay, fine, let's also start domestic production of solar panels. And then production or manufacturing of solar panels was made a part of Make in India campaign. So as soon as that happened, it also meant that we'll stop importing from the US. Will not import the solar panels from the US. US, of course, did not like this, because the domestic market of US was hugely dependent on Indian imports. So all of a sudden, India saying that now we are not going to import anymore, it also means for the US that it's not going to be very easy for us to supply to somebody else all of a sudden overnight. And that's why the jobs that have been created in this sector in the US, because they have to manufacture so much for India, all those jobs will be threatened. So that's where the domestic market of US, that would be threatened, and that is something that was not liked by the US. and a controversy also happened here. India was even dragged to the WTO by the US. But India said, made its point very clear that look, today the way we are moving, the way we are, we would need a lot more production of solar energy components compared to the imports that we have right now. So that's why we can't just rely on a foreign country for all these instruments, because first of all we have to make it much more cost effective as compared to where we are. And then it also doesn't help the fact that we are never even eyeing for a domestic production. So ultimately we started the domestic production. Although we started the domestic production, we did not overnight ban the imports. Slowly and steadily the imports were decreased, and ultimately we started producing much more number of solar panels in India as compared to what we were producing. So that's why the National Solar Mission, it becomes a very, very important part of our entire energy setup, and hence it makes it very, very crucial from the perspective of your examination as well. Now, overall, when we look at solar energy, so one more point to add when it comes to the National Solar Mission, the target that we had taken was 100 gigawatt. This 100 gigawatt target was divided into two parts, one component of 60 gigawatt and one component of 40 gigawatt. This 60 gigawatt component was through grid connected solar power. Grid connected solar power, and this 40 gigawatt basically is the target for rooftop solar power. So we wanted that rooftops of the buildings can also be used, of course, and from there on also we can actually generate a lot of solar energy. Now, when you look at these targets, so of course these were the targets for 2022. So out of these targets, what you will see is that out of 60 gigawatt, we were able to do a good job, and we almost reached, almost I'm writing, almost 50 gigawatt. Almost between 50 to 53 gigawatt is what we reached out of this 60 component. But out of this 40 component, we could not do very well, and almost just between 10 to 12 gigawatt is what we have been able to achieve. So on one hand, almost 90% of the target was achieved. On the other hand, only about just 25% of the target was achieved. And that's why this part of rooftop grid connected rooftop solar energy, this became the problematic part. This became the part that led to a decrease in the achievement of the goals. This part of the scheme was given the name Srishti, rooftop solar power. This was given the name Srishti. So this is called as the Srishti scheme. All right, this is called as the Srishti scheme. So in this manner, we see that this was the setup according to the National Solar Mission, but we could not really get to the required goals. Now, apart from these things, we have seen that there have been certain innovations also that have started coming in solar energy. And one of these very crucial innovations for the future of solar energy is solar tree. Now, this solar tree as a concept is basically nothing but, instead of using a horizontal setup of solar panels, we want to have a vertical setup of solar panels. How exactly? Look at this picture. So what we basically are looking for is that instead of using this on the ground, just laying down all these solar panels on the ground, we want to raise it to a height, and that's why use it like a tree. That's why the name solar tree has been given. So now in this case of a solar tree, we see that this has a very big advantage, and rather it solves a very big problem that solar energy has. That solar energy would need a lot of solar panels, correct? All these solar panels, they are horizontally laid down. These are horizontally laid down. Because of that, we waste a lot of land, right? We waste a lot of land, and many a times this land is agricultural land. So when you are using it for not agriculture but for solar energy, or let's say for any other purpose, it's not an optimized use of resource, because the agricultural farms, the first duty that the farms would have is to help in production, to help in agriculture. But now we are trying to use it for something else. So that's why it's not a good utilization of the resources available. So that is why when you raise it to a height, when you have a vertical setup, it actually gives you an advantage there. So that's why the concept of solar tree. Similarly, there is another concept. There's another concept that India already has been working on, is floating solar panels, or let's say floating solar power, or let me write panels, it's better. Solar panels. Now with floating solar panels, basically the thing is that this is where you will keep the solar panels on the body of water. The installation will be done on a large body of water, largely like, let's say, things like lakes, etc., is what we'll be using. Now, overall, what happens is that this is also an innovation trying to solve the same problem that solar tree is trying to solve, that we want to take the sections away from uh, land, and that's why they'll be able to help in conservation or preservation of the land resources and better utilization of those land resources. So that becomes floating solar panels. So it's not just about the future, but you'll see that in the past couple of years, some of the states already have a floating power plant now. For example, we have it in Andhra Pradesh, we have it in Kerala, we have it in Chandigarh, and now India is also planning to build the world's biggest floating solar panel, or floating solar plant in Madhya Pradesh. So that also is in under development right now. But overall, we'll see that all these things will really help in the coming future. So that's why this is also an innovation that becomes very, very crucial. Then apart from this, so that's why when we look at the advantages, let's say for solar tree, it reduces the land requirement, one of the most important use here, viable for both rural and urban areas, address the increasing demand for green energy. Project can be very useful in decreasing the problem with electricity supply, that wherever we have electricity supply which has frequent power cuts, etc., solar setup can be done, solar tree setup can be done there, and maybe the local utilization of solar energy can be done in this manner. Then it is environmentally friendly, and of course can also help in increasing the farm income. How exactly it will increase the farm income is on the basis of the fact that these farmers, whoever be the farmer who provides access to their land for utilization or setting up of solar tree, they will also be rewarded for this, they will be compensated for it. So it will be helpful for them in increasing the farm income. So that's why there are all these various advantages that something like a solar tree would have. So now that's why there are various different ways, there are different programs and policies that India has been working on. Nationally and internationally, we have been taking a lot of steps. For example, there is something called as an international we have the International Solar Alliance, correct? We initiated this International Solar Alliance. So this International Solar Alliance also has been one setup that establishes the sincerity with which India wants to implement solar energy. And also, we have included a lot of other countries, most of these countries being tropical countries, making these countries also realize that because we have the best intensity of solar energy available anywhere in the world, it also becomes kind of our responsibility to also utilize this solar energy as much as possible. So, India started this International Solar Alliance. At the same time, domestically, there are other ways in which the people are also being trained. So, for example, there is this Surya Mitra scheme. There is this Surya Mitra scheme. Now, the purpose of Surya Mitra scheme is training. All right, training of people who have completed their 10 plus 2, people who are graduates, and all these people will be trained in the field of solar energy in a manner that tomorrow, if they want, they can become a part of the entire setup, because this is going to be a growing industry. And of course, we do see the kind of growth that we have seen in solar energy in the past few years, and this will continue in the coming years as well. So that's why there will be a lot of opportunities that will open up. There will be a lot of employment generation that would happen through solar energy. So that's why Surya Mitra scheme actually helps in all these things, because it is nothing but a kind of a training program for the future. Correct. And that's why Surya Mitra scheme becomes important. So until now, as per as one data that I saw for the last year, that until now almost 52,000 people have been trained as a part of the Surya Mitra scheme, out of whom almost 26,000 people also have received some kind of job opportunity as well, because now they are specialized. Correct. So now that they are specialized, they would be able to help better when it comes to solar energy. So that's why there are all these efforts. Uh, there are other such schemes as well, but overall we do see that there is a lot of emphasis that is being put on solar energy by India and by everyone else around the world as well. So the advantages of solar energy: it is a renewable source, environmentally friendly, wide availability, that we are not dependent on somebody, we don't have to mine it out of the earth. So that's why availability is fine. Versatile. Versatile means that it can be used in various different forms. So what we discussed is that it can function as heat energy, it can function as large light energy as well, and can be used in various different ways. So that is what is called as being versatile. Then after that, low noise. Low noise is a big factor, because when it comes to, let's say, something like a coal fired thermal power plant, there are so much of machinery around it that it will really create a lot of noise. Even wind energy, for example, creates noise. So compared to that, solar energy does not have these problems. The maintenance requirements are low, and that's where the return on investment is very high. So that also adds to the advantage. It can become a remote and portable power option as well, that it is just about a local setup that you can do anywhere. That's not the problem. That's not the case with, let's say, something like the thermal power plants, because then there are very specific ways in which you can provide power through them. So just for a remote location you can't, but solar energy in this fashion also very easily it can be used. Then it also will help in increasing the energy security of the country. Now, what do we mean by energy security? First of all, energy security is when, from the perspective of energy, we are secured, that we don't have to rely on some other country for our energy needs. Unfortunately, in India, the conditions are different. That today, especially for petroleum, we do rely a lot on a lot of different countries. So, for example, whenever any international controversy happens, I'll give you two examples. One, when US started sanctioning Iran, when economic sanctions were put on Iran, US also asked India to stop importing petroleum from Iran. Now, for us, Iran back then was the second highest importer. So that's why it's not even possible for us to even think that overnight we'll stop taking oil from Iran, because US does not want us to take oil from Iran. But at the same time, uh, we can't go against US as well. We have a very strong economic connect with the US, and US also provides supplies energy to us. So in that scenario, it's not easy to go against US, and we don't want to go against Iran as well, because Iran also has been a kind of strategic partner for India for a very long time. So that's why now that we are dependent there, we have to take a step, and at least one of the two parties will not like what we are doing, if not both, for example. So that becomes an issue. Earlier, we have seen last year also, after the Russia Ukraine issue, that India started buying cheap oil from Russia at a much cheaper rate as compared to the international markets. And this is where also it created a lot of controversy, that uh, it was believed that India should not buy oil from Russia, mainly because Russia has launched an attack on Ukraine, and all the European countries and the US are on the side of Ukraine. So they wanted other parts of the world also to be on this side. But when it comes to a country, let's say when we are talking about India, priority of the priorities of Indians would come first. So first, the country would want to secure the future of this public, correct? So for that, wherever they are getting cheap oil from, we perhaps would accept it, correct? So that is the scenario what we see in this particular case as well, that energy security becomes very crucial. And because we are not secured with our energy sources right now, it creates a condition for us where internationally we many a times are put in a spot where we have to choose a side, and we don't want to choose a side. We always have had a long aligned foreign policy, but that cannot work really well if we don't have energy security. So that's why solar energy will become a very important part of this particular system. Then after that, it is an evolving technology. Everything, every day we see that there are new additions happening, there are new improvements happening. So there are all these things, and that will also help us increase our capacity altogether. So overall, this will also lead to a lot of job creation. It will also help a lot of people get jobs in the sector of solar energy. So that's why there are all these advantages that we have with solar energy. After this, looking at some of the problems, first is expensive. Now, although it is expensive in the initial part of our journey, but what we see is that when you are looking at solar energy for a long period of time, you'll see that the return on investment is very good. So that's why it will, when it comes to the cost, let's say in a 20-year or a 15-year span, this will be much better. So that's why expensive only in the beginning, but not always. Then another problem, that it's a daylight only solution. You don't have sun in the night, so you don't have sunlight in the night. So that also becomes a challenge. It is vulnerable to atmospheric conditions, especially when it comes to air pollution. We have to consider this as well. Air pollution can become a factor. Then even fog or a smog situation can become a problem, correct? So there are all these things, plus any rainy or cloudy day, we'll see that in all these cases it's not easy to produce energy from solar from the sun. So that's why atmospheric conditions can play a big role in we not being able to achieve the targets that we have set. Then large footprint, we discussed about this as well, that it occupies a large amount of area on the ground, correct? So this basically means that it occupies large area on land. And then manufacturing pollution. So manufacturing pollution is basically the kind of pollution where, because of the manufacturing, some pollution has been produced. So for example, let's say when solar panels are being produced, so solar panels have come from semiconductors, plus there is glass, plus there is plastics, etc. In all these cases we see that manufacturing is being done, and while the manufacturing is done, some emissions might happen. All right, some emissions of some air pollutants might happen, although compared to the fossil fuels it is just a fraction. It is nothing but a fraction. So that's why this is not a big challenge altogether. But yes, since we are counting, this has a small amount of problem. So this is this is about solar energy. But before moving to wind energy, if you have any questions with regards to whatever we have discussed. Why we use semiconductor only in solar panel rather than conductor? See, for conductor, basically when you supply electricity to it, conductor will start working. It will just allow the flow of energy. But it doesn't happen through solar, correct? That if you, let's say, have something made of iron and you keep it in sunlight, nothing will happen. It's not that it will ensure that electricity supply is set up now, because all the electrons that we had discussed, that they are randomly arranged, they already have an arrangement in the conductors. So that's why sunlight does not play an external role. But in this scenario of semiconductors, we see that their properties are unique, that when sunlight is incident, they actually start when sunlight is incident, they actually start arranging in a particular direction, and hence flow of electricity. What does expandable launch system mean? No, it's not expandable, it is expendable. Meaning expendable. Expendable. Expendable means something that can be reused only one, which will be destroyed while it is being used. That is called as expendable. So we had discussed in the last class that uh, we are working on the renewable, sorry, no, not renewable, reusable launch vehicle. So that reusable launch vehicle is called as non-expendable. What is PV array? PV array is photovoltaic array, meaning the solar panels, the set of solar panels. How do they clean the solar tree panels? I mean, a normal method of cleaning, where however you clean glass, you can use it. Green energy. The meaning of green energy basically is anything that is renewable, anything that has a positive impact on the environment will be called as green energy. The word that is used is green energy. With COVID, solar process was slowed. Yes, absolutely. Many of these kind of projects for the future, they were drastically impacted because of COVID-19, and at least for a year or more than a year, actually, they haven't been able to work very. They haven't been able to work properly. So yes, that's, I would say, yes, that's the problem. All right. So let's come to the next topic, and this is wind energy. Now, in terms of wind energy, what we basically see is that wind energy is the energy that we are getting from wind. So, what is wind? Does somebody remember a very simple definition for wind? Although there is an elaborate definition that I have given you right here on the screen. A simple definition, if somebody remembers from the early classes, what is wind? A very simple way to put forward what sort of you have said, or Lokesh, you have said, movement of air, flow of air, correct? So in classes 4 or 5, you will be taught moving air is called as wind, correct? So this is what we are saying, that moving air is called as wind. So then there are various different ways, or there are various different factors which lead to this kind of a movement, that, as Himanshu, you have mentioned, that it's a horizontal flow of air. So we are talking about the movement of large masses of air which are caused by the differential heating of the atmosphere by the sun, irregularities on the surface of the sun, and rotation of the earth, correct? So how do we define wind? So how do we define wind? That will say that this is a kind of kinetic energy associated with the movement of large masses of air caused by the differential heating of the atmosphere by the sun, irregularities on the surface of the sun, and the rotation of the earth. So, so these are the three basic factors that can lead to the production of wind. And these are things, or these are factors that will never end. For example, the differential heating will always happen because of the atmosphere. The irregularities of the surface of the earth is never going away. Rotation of the earth is not going to stop. So that's why these factors are always going to be here, and that's why wind energy is again a renewable source of energy. Now when it comes to wind energy, there are certain criteria to be fulfilled so that wind energy can be utilized well. So there are two factors, there are two parameters that we always keep in mind. One, the minimum speed. The minimum speed basically is 15 kilometers per hour. Minimum speed is 15 kilometers per hour. And then, if meaning that if the wind speed is at least 15 kilometers per hour, then we can make the use of that source. And second, the height of installation should be at least 100 meters above ground. So these are two basic parameters which are followed in India when it comes to wind energy. Now, wind energy, of course, it needs large masses of air to flow. So you should not have any obstruction, anything coming in the path of the movement of air. So that's why the urban areas, they become very very difficult to sustain wind energy. So that's why the setup, you will see that they largely will be in areas which are away from any kind of urban settlement, where you don't have a lot of people, you don't have a lot of urban infrastructure, and not only urban infrastructure, perhaps even the forest. So because the forest or dense forest can also hinder the movement of air. So that's why they'll be kept in areas where you have better movement of air. And that's why when you look at the top 5 wind energy states in India, you'll find that 4 out of these 5 states are coastal states, and the fifth state is Rajasthan, which also has large open areas due to the desert. So that's why the top 5 states, you start with Tamil Nadu, then Gujarat, Maharashtra, Karnataka, and Rajasthan. These are the 5 states, top 5 states, which produce the largest share of wind energy in the country. Now, when it comes to wind energy, we know that there are variations also that happen in the wind. So, because of these variations, it becomes very, very difficult at times. Correct? It becomes very difficult at times to get that energy. So, that is why we always have to ensure that the areas where the setup is being made are the areas where we are expecting that a better flow of air keeps happening all the time. And that's why the coastal areas become much better, and compared to that, the continental areas are not. Because even, let's say, for example, if you consider North India, then in North India, what we would observe is that after a point in October or November, the winds start becoming much calmer. The force with which air flows is very very less. So air becomes stagnant, and because of the stagnance of air only, we see that they would lead to fog-like situation, or if pollution levels are high, then smog-like situation. So these kind of situations would arise because wind almost becomes stagnant in the winter months. So that's why we always have to look into this regionality of wind energy also, that it's not that everywhere we'll be able to set up wind energy. So overall, that's why when we look at wind energy, what we basically see is that uh, we can use wind energy in this manner, that there will be a movement, the flow of wind will happen, it will lead to the movement of the fans. The movement of fans will basically produce kinetic energy, and this kinetic energy ultimately will be uh, converted into electricity. Correct? So this is conversion of kinetic energy into electricity. Kinetic energy into electricity is, this is basically what happens in wind energy. That first, rotating generator converts wind energy into electricity. Transformer increases the voltage here, and that's why it will be carried on long distances through the grid, and ultimately we'll see that this is where we'll get energy from. So this is how we get wind energy altogether. Now, when it comes to wind energy, we see that although coastal areas are very, very important, but then there is a new setup also that we have started working on. And this new setup is called as offshore wind energy or offshore wind power. Now, in case of offshore wind power, this is a setup that we are doing on the body of water. This is a setup that we do on the body of water, hence it is called as offshore. So in the continental margins of the seas and oceans, these are the areas that we'll try to use for offshore wind. Now, why offshore wind? Because first and foremost, when you look at the sea and the ocean areas, they of course have very wide open spaces, correct? They have wide open spaces. So because of that, the flow of air is much better. The flow of air is much better, so hence there are higher chances that we'll be able to increase our efficiency of wind production from these kind of offshore wind power. So overall, that's why we see that there are all these things that we have been able to achieve, uh, and we already are moving towards a target. So for example, let's say when it comes to India, India now has an offshore wind power target that we have kept as a pilot project. That as a pilot project we have taken one one program, and this is a setup that we are doing off the coast of Gujarat, that in the sea area, Arabian Sea area of Gujarat, we are doing one pilot program. We are running one pilot program for offshore wind. But later on, we'll see that two states have been chosen, Gujarat and Tamil Nadu. Gujarat and Tamil Nadu, these will be two areas where the government will be setting up a lot of offshore wind power. So that is where we have now started with, and we now have started giving some importance to it. Recently, what also happened is that the government of India also collaborated with the government of Denmark. We also collaborated with government of Denmark because these areas, the northern European areas, they already have been using offshore wind a lot, and they have the expertise with offshore wind. So that's why we want to use their expertise in also setting up the same in India. So that's why these two governments will be working together in ensuring that India can also increase its efficiency with renewables with the help of offshore wind power. So overall, although offshore wind power in the entire world, the setup is not very huge. So for example, you'll see that the entire world combined uh, has almost 60 to 63 gigawatt that we have currently. So just 60 to 63 gigawatt, the whole world combined. This is the end of 2022 report. Now, in this particular scenario, what we also see is that we are slowly and steadily increasing. Some of the countries are investing a lot more in this. For example, let's say China. For example, China has been spending a lot of money in offshore wind power, and that's why very soon we perhaps might see that China will become number one country with offshore wind capacity. Right now, it's the European countries which have the largest capacity. So that's why overall we see that all these cases, uh, offshore wind can become very important, and that's why today we also have a national offshore wind energy policy. Basically, we are looking at all the various aspects of how offshore wind can be used, and what is the infrastructure requirement, how much of investment is required, where will the investment come from. So all these things we basically have taken as a part of the national the national offshore wind energy policy, and this will also help us reduce our overall consumption of the fossil fuels. So in the future we'll see that this will become very crucial. So just know all these points. These are factual points. I've just mentioned it so that it will help you in revising, but there are all these different things that have been taken as a part of this policy so that India can make the use of offshore wind power in the future. Now, what are the problems? What are the challenges in harnessing this? That first and foremost, it needs a lot of data collection. Needs a lot of data collection. That first and foremost, wherever you are suggesting the plant be set up, you have to first check for the wind speed. You have to check for the seasonality of the wind, that whether there is a flow that happens all throughout the year. Then, apart from that, you will also have to ensure that there are no external factors that can lead to the destruction of these plants. So, for example, let's say if we are setting up these plants in areas which are prone to cyclones, all right, especially let's say the eastern coast of India, especially let's say Odisha. So it's very difficult to set up a plant in Odisha or off the coast of Odisha, because we know the kinds of strong cyclones that Odisha very often fights. So that's why we'll have to first check that, and not only the historic data, but we'll also have to predict for the future, that if you are installing a offshore wind plant, you are not doing for a year or 2 year period, that in 1 year it completely gets destroyed, and again you are going to infuse a lot of money to set up everything. So that's not going to be very easy. That's not going to be easy to for us to even think that something like this can be done. So that's why a lot of data collection, a lot of data collection to ensure the safety and the efficiency of these plants. All right. So offshore entails a lot of data collection. So basically, this is about analyzing wind speed, natural calamities, and also seismicity chances. So all these things will have to be done so that we can ensure the safety and the efficiency of the offshore wind power plants. Then after that, a lot of investment is also required here, because setup is not that easy. The entire setup, the infrastructure is not that easy to set up. So of course, it needs a lot of cost for the setup to happen. So So that's why that is also one of the problems that we have. Then in Europe, because the European countries are the ones which actually have the biggest setups right now. So in Europe, what we have seen is that this entire thing could work well, because there were years of incentives also that were provided for everyone who was working in the sector, and such a support is completely missing in India. So that also becomes a big challenge altogether. That in India, whatever projects are being taken, whatever pilot projects we are working on, it's completely the government of India that is working, and there's no private company involved here. And private companies largely will be involved only in places where they also see a lot of profits. Otherwise, they have to have a very strong backing of the government, that anything goes wrong with a company, the government is ready to bail out the company out of all those troubles. So that's why we see that it's not that it's easy in India to get the private companies to work on these kind of projects. And then one last problem, that right now even solar energy is cheap, and onshore wind energy is also itself just developing right now. It's not that we have a completely developed onshore wind energy plants right now. So that's why you can't even say that, okay, fine, you start working on offshore, forget about solar, forget about wind energy, start working on offshore wind energy. So that also is not something that can be done. So it also adds to the problem that we right now are trying to stabilize the energy sources that we already have, so that we can work on those energy sources first, and then after that perhaps we can move to the new ones. Then after that, there is one more policy that the government is working on, which is national wind solar hybrid policy. Now, as a part of this, what we want is that we want to have a hybrid structure, meaning that wherever we have, let's say, wind energy plants or solar energy plants, at the same place, we also want to set up the other. So for example, let's say wherever you have wind, set up solar there. Wherever you have solar, if possible, set up wind there. So that the same infrastructure can be used for these two together. And that also will help us optimize the resources that we are using in all these courses. So all these situations. So that's why we see that national wind solar hybrid policy will also be very, very important from this perspective. Then looking at overall the advantages that wind energy has, many of these advantages are self-explanatory, I would say, that they are renewable and sustainable, they are environmentally friendly, reduces fossil fuel consumption, wind energy is free, small footprint, right? Small footprint compared to solar energy, where the footprint is very large, correct? Industrial and domestic installations are possible. It can become a remote power solution as well. Maintenance requirements are low. It increases job security, energy security, and also can lead to job creation, because this is also something that is growing day by day. So advantages, I would say, more or less they are self-explanatory. I'm sure that you have understood it. If not, you can ask it. Then the disadvantages, the problems that we have right now. First, the wind fluctuations. First problem is wind fluctuations. Now, when it comes to wind fluctuations, what we understand is that at least 15 kilometers per hour should be the speed. If we are not able to get that speed, we perhaps will not be able to get the best out of wind energy. Then installation here also is expensive, although return on investment here also is good. So, here also we can write, although the return on investment is good. All right. Then there is a threat to wildlife that we have here. We'll discuss about this particular point. What is this threat to wildlife? Then noise pollution, because constant movement of windmill. So people living nearby, it will not be a good experience for them. And then there is something called as visual pollution. So visual pollution is basically in any setup where you have an artificial setup. You have an artificial setup in a natural environment. This is called as visual pollution. All right, this is called as visual pollution, and this is the case that you are choosing off locations and placing all the windmills there, so that also is something to be considered. But the most important problem to be discussed here is the threat to wildlife. That overall what we see is that wildlife can be largely threatened because of wind energy, and there are instances also where we have seen this happen. How exactly? Just understand this. First problem is the problems that we see with the birds. Now, the movement of the fans will happen wherever you have the setup of the wind farms. So, for the birds to fly in these areas becomes very challenging, and we'll see that the birds will start avoiding these kind of areas. Now, birds avoiding these areas also means that, see, birds would fly why? So that they can collect food from nearby areas, maybe help in movement, maybe help in feeding their young ones, even for, let's say, reproduction, they might, or even for migration, they might, for one reason or the other, search for food. There are so many things, right? So, the movement of the birds, they get hindered. They would not move there. They would understand their security issues. So what then happens is, movement doesn't happen, they can't collect food, and ultimately this leads to some negative scenarios that we produce for these birds. In extreme possibilities, we might see that the bird may move to a new habitat, that they might not think that this habitat is safe enough for them anymore, and hence they might shift to a new habitat. Now, it's not easy to move to a new habitat, because every habitat will have its own ecosystem running. Correct. So there is a food web or a food chain that everywhere is present. So whatever part of the food chain this bird is supposed to occupy, there must be some other player which is already occupying that. So now there will be a competition between the two species. And this kind of a competition is never good in any ecosystem. So that's why lives of the birds will be threatened. And in extreme cases, it might lead to even, let's say, not only death of the bird, but even extinction of the bird. So that's why there are these cases to be considered. At the same time, one more problem with wind energy is that there is no environmental impact assessment for wind energy. Now, environmental impact assessment is something that the government does whenever any big project, any big infrastructure project, etc., is being taken in a natural surrounding. So then, in that case, what happens is that they have to understand and evaluate whether or not it will have a very distinct negative impact on uh, on these kind of areas. All right. So so let's say hydroelectricity power plants, the big dams, whenever constructed, an EIA will be done, an environmental impact assessment will be done to understand whether they can have a negative impact or not. So overall, that's why EIA helps there. But in case of the green energy sources, the clean energy sources like solar energy or wind energy, these are exempted from EIA procedures. That there will be no environmental impact assessment that will be done for them. So whether they are positively or negatively impacting the environment, nobody would go and question that. And why exactly? Because we are saying that this is wind energy, which is already a clean source of energy. So why do we even need to do environmental impact assessment? But you have to understand the importance. All these areas wherever wind farms are set up, high power transmission lines will be running, so that all the power generated can be taken to the substations. Now these high power transmission lines, because of these, many a times what may happen is that a bird might come and get electrocuted because of that. All right, if they get electrocuted because of that, they die. And we have seen these instances. We have seen these instances in Gujarat, in Rajasthan, in Karnataka. In all these areas we have seen these instances. And not only of a normal bird, but even an endangered species, a critically endangered species, might also fall to the trap of this high power transmission line. So for example, there has been an instance where a great Indian bustard, was basically had lost its life because of this. Great Indian bustard. Now, the thing about Great Indian bustard is that this is critically endangered. This is critically endangered. You know how many do we have? Okay, just a trivia question for you. What are the parts of the world where you find the Great Indian bustard? And what do you think is the total number of Great Indian bustards approximately left in the world? Two questions for you. I'll give you the answer, of course. Yes, Lokesh, your answer is correct. Gulam, your answer is also correct. Saurabh, almost there, but I'll tell you the context there also. And the number. Okay, many of you have now uh, guessed that this is the area, but can you guess the number? How many left? So the thing about Great Indian Bustard is that initially it was found in India, in Pakistan, in even Nepal. These kind of areas it used to be found. Now it is only left in India. In the entire world, the Great Indian Bustard is only now found in India, and that too majorly in three states: Rajasthan, Gujarat, and Maharashtra. In Rajasthan, we also have a bird sanctuary, which is basically for the conservation of Great Indian Bustards. Apart from that, in Gujarat and Maharashtra also they are found. Now, what happened is that there was one instance there where one Great Indian Bustard, it got electrocuted from a wind energy high power transmission line and lost its life. And then there were questions raised that these kind of things we have to think about while setting up even a power plant, which is, or a wind farm also. The number is almost 150. The count is almost 150 that is left. So only 150 in the entire world, and that too on also in India. So that's why out of such a small number that is already left, losing even one would be disastrous for us, and that's why we want to avoid such situations. So that's why threat to wildlife is the biggest challenge that we have right now when it comes to, especially when it comes to the disadvantages of wind energy. All right. So this is about wind energy. Next is geothermal, but let's take a break here. Let's take our lunch break here. And on the other side of the lunch break, we'll talk about geothermal energy. We'll talk about biofuels, and then we'll move on to nuclear energy towards the end of our sessions today. So geothermal energy. So I think the new link that will be available for you will be at 3:40 p.m. So please be back by 3:40 p.m. and let's have further discussion on geothermal energy.
पुण्याच्या मुलांमध्ये